And we will now turn to the other three panelists, which, if I can characterize it, and I hope I don't mischaracterize it, take a bit more of a methodological approach to the issue. And I wouldn't be surprised if Ralph Keeney, who is the next panelist, takes a decision analysis approach to the sustainability issue. Ralph.
Thank you, Detloff, and it's a pleasure to be here. IIASA's mission in the strategic plan that Detloff referred to in these opening remarks states that IIASA provides insights and guidance to policymakers worldwide for finding solutions to global and universal problems through applied systems analysis in order to improve the human and social well-being and to protect the environment. Now, what way can IIASA affect how well they achieve that mission? It's through the decisions that they have to make. They make decisions about what analysis to do, what stakeholders' views to include, and as Bill mentioned, what stakeholders maybe to even include in the analysis in the front end, some of the policymakers at the back end, those people, which is everyone, influenced by the policies they're making. And that's what I'd like to talk about. I think there's some opportunities for some methodological contributions that are not often in typical systems analysis models. And IIASA's mission sets up the frame that you'd have for a systems analysis model. It's this little green box. It was a little different earlier. And the input is the policy alternatives or options that you have that you can choose, or solutions. There are different names for these things. And the output is, of course, in the mission, it's the impact you have on humans and their environment. You want to be much more specific about each of these, the alternatives and the output. But what do we typically have in systems analysis? Not that this is negative at all. It's very difficult to do everything in the problem. And a lot of great systems analyses are done that capture much of the problem and much of the complexity, but they miss some important gaps. And it's those gaps that I think are worth talking about. The inputs to a lot of analysis, as David said, are scenarios, crucial to any analysis that you're going to do. The outputs are indicators of what the impact on humans and the environment might be, but they're not directly the impact. The closer we can come to finding out what those impacts would be crucial. I'll give examples in a moment, but when there are these types of gaps, I think the quality of insights for policymakers and for creating better alternatives sometimes, as David's example shows, the integrated alternative would be one such creation. The opportunities to get those insights and create the alternatives is degraded a bit, and we could do a little better, and I think it may be worthwhile. So, for example, when you look at the gaps, one of the gaps is in the front end. You cannot choose which scenario you think you'd like to have and get it. You can choose alternatives that will influence the likelihood you have those scenarios. So, for instance, a scenario in very simple cases in some models might be the 20% of the energy would be from renewable resources in 2020 on Earth. Now, you can set policies that says that's a goal. That policy would be an alternative. But it doesn't mean you're going to, of course, end up with that 20%. There's uncertainties of where will you end up. And that's the gap between the alternatives and the scenarios are worthwhile working on. There's a gap at the other end as the output. Because if the output of a global warming model is there is 2% average warming on Earth, so what? We want to know what are the implications of that. Now, many of the people on the panel in the room have good insight about that, but overwhelmingly, the people in the world don't have much insight about that. And what they care about, of course, is how many people might lose their home from flooding, etc. And there's scientific evidence that would suggest how you would model that, and people have modeled the relationship from the warming to the melting of icebergs, etc., to the water level, and who would be inundated, who would have to move, implications like that. And then there's a third category that's often not in, quote, scientific models, is the impacts that are through the pathway of the economics and the human behavior based on economic incentives and others that cause consequences that are of interest in the problems that we're looking at. And the economics are important to have there because among other things, it indicates what are the things that we are not able to address because they cost money. So let me just mention what we need to do, or I think there's opportunities to do. The output here is very complex. Multiple objectives, risks, things I would ask to talk about, and how does one integrate that all together? You need some type of an objective function, even if you can go through the whole front end to the back end here, of what types of consequences are better than others. And you really evaluate them before you know what the consequences will be, so you have to evaluate alternatives given the uncertainty of those consequences. And for that, to get an objective function, you can build a value model. It's based on the values of stakeholders, policymakers, people that you care about the impacts to, etc. Why would you do that, and how would you do it? Exactly like any model. It's complex, it's hard to do in our heads. If we break it down into parts, we can do a better job likely than having one person process that all through their head. And it fits on the end here. That's a standard thing that can be done. And what is the knowledge you need for these? Well, typically in the systems analysis models, it's scientific, and as Bill mentioned, it's integrated now much more, but it's often based on the hard science. Soft science is relevant to that, and I mentioned those up here: engineering, mathematics, physics, etc. And let's look at the model at the back end here. That is based on hard science too, and we can couple them. If there is certain level of global warming, we can follow through the implications with knowledge from different sciences to get how many people might be inundated. You need, obviously, where people are living and some of that from geological sciences, etc. Now, the other models need the softer sciences. How organizations and individuals will adapt to the policy. If a policy is set, the implications that you have in scenarios depend on what people will do given that policy, what organizations will do, etc. In the red at the bottom, the economic costs, obviously, that's a different thing, and there are models to get estimates of those, and there's large uncertainties about them in many cases. And then there's uncertainties about what humans will do there to adapt that affect the consequences. And then in the value model, you also need the softer sciences, those decision sciences, economics, political science, and certainly those sciences are crucial to include in a model. So to summarize, I think there's some real important opportunities that IIASA has. If you look at a model like this, 90% of the effort and probably 90% of the complexity is in that middle part. And you gain some great insights from that if that's done very well and communicated well. But with the additional 10%, if you fill in those gaps and build the value model, you can get greater insight, well worth the time and effort, I feel. And as a scientist, I feel obviously it's worth more experiments in how to do this and do it well. And I think that would be well worth the effort for IIASA and for the goals of IIASA as stated in their mission. Thank you.